Okay, so today we're going to be talking about solving equations with variables on both sides of the equation, or both sides of the equal sign with grouping symbols. So this is going to be very similar to the last lesson where you solved equations with grouping symbols. There's just going to be kind of almost one more step, but not exactly one more step. It's a little bit funky, but essentially what you're going to want to do is you're going to want to distribute. So whatever's around those parentheses, you need to distribute into the parentheses, and then we're going to follow the same steps we use to solve any equation with variables on both sides. So we're going to move the variables to one side, isolate the variable, also known as moving all the regular numbers to the other side, and then simplifying. So that's just changing whatever's in the term with the variable, whether it be like 8x or x divided by 8. We're getting that variable all alone to get our final answer of our variable equals a number. So like g equals 4. Then let's get into some examples. So example 1, we have 7c plus 2 equals 4 parentheses c plus 1. So our first step is going to be to distribute. So we want to distribute this 4 into the parentheses. So we need to do 4 times c and then 4 times 1. So I'm just going to copy down the rest of the equation. 7c plus 2 equals, and then 4 times c is 4c, plus 4 times 1 is 4. So now, once you get to this point, we're going to solve this just like we did back in 2C, where we were solving equations with variables on both sides. So first step, we're going to get the variable on one side. So I want to move the 4c to the 7c. So in order to get rid of a positive 4c, I need to subtract 4c. And of course I do that on both sides because we want to keep the equation balanced and happy. So we're left with 3c plus 2 equals 4. Now we move on to our third step, which is to isolate that term with the variable inside of it. So in order to isolate that term, I need to get rid of that plus 2 on the left-hand side. So to get rid of a plus 2, I do minus 2, because we do the opposite of the operation that's present. So subtract 2 on both sides, keep the equation all balanced and happy. Did I make a mistake somewhere? No, it's just a messy equation. Okay, cool. So we're left with 3c equals 2. And that is our third step. And then our fourth step is finally just to split up that term with the c in it. So we want to, right now that term is 3 times c. We want it to just be c. So we're going to divide by 3 on both sides, keep the equation balanced and happy, and we're going to be left with c equals 2/3. And that fraction is already in its most reduced form, so we can circle that and say that's our final answer. Our next example, we have grouping symbols on both sides, which all that ends up meaning is we get to do twice as much distributing, which is all fine and dandy. So first thing we're going to distribute is we're going to distribute the 6 into the k plus 1. And at the same time, I'm going to distribute this 1/2 into the 4k plus 14. So looking at the left side first, 6 times k is 6k. And 6, oh, that was a really nice k. Good job, Mr. Wright. Good handwriting. 6 times 1 is 6, so plus 6 equals. Now, half of 4k is 2k, because if we're multiplying by half, that means we're really dividing by 2. So half of 4k is 2k. And then plus half of 14, which would be 7. So that's our distributing. Now our next step, we have to, just like we did before in 2C, we have to get our variables on one side. We need to get them all to the left side. In this case, I want to move the 2k over to the left. So in order to get rid of the positive 2k, I'm going to subtract 2k. Do it from both sides, keep that equation nice and happy. Left with 4k plus 6 equals 7. Boy, these are just all messy today. I did a terrible job writing these equations, and I apologize for that. So, moving on to our third step, we need to isolate the variable. So we want that term with the variable left all alone, and to do that, we need to get rid of that plus 6. So I'm going to subtract 6 from both sides, cross that out. So we're left with 4k equals 1. Then our final step is to split that term up with the k. So we have 4 times k. In order to get rid of the 4 times, we just need to divide by 4. And of course we need to do that on both sides because we need our equation to be balanced and happy. So we're left with 1/4. K equals 1/4, which of course is in its most reduced form. And so we're happy with that as our final answer. Now our final example, this is our messiest equation by far. The answer comes out clean, but it's messy to start with because we have this fraction on the right side. But just as we've done before, we need to distribute this 3 for our first step. So I'm going to distribute that 3 into the 2x minus 10. So let's copy down the left side of this equation, which remains 8x. And now let's distribute on top of this fraction. So 3 times 2x is going to be 6x minus 3 times 10, which is 30. And of course, this whole chunk is still over 2. So now this is where the equation kind of gets funky. We can do it one of 2 ways. And they both work out pretty well in this case because the top of this fraction has 2 even numbers. We could go ahead and divide by 2, or we could times both sides by 2. So what I'm going to do here is I'm going to split this, and we're going to solve it 2 different ways. And it's really just user preference which way you choose to solve it. So I'm going to copy down both of these equations here. So 8x equals 6x. Let's erase that. I think you guys get the point of us splitting this. 6x minus 30 over 2. And then the same thing on this side. 8x equals 6x minus 30 divided by 2. So let's look at this left side first, and we'll solve that all the way through. So this first way is the way that I would do it. I would multiply by 2 on this right-hand side to get rid of the fraction, which means, of course, I have to multiply by 2 on the left-hand side to keep my equation balanced and happy. So I'm left with 16x equals 6x minus 30. Now, I still need to move the variable to one side, so I'm going to subtract 6x from both sides, which leaves me with 10x equals negative 30. And now I need to isolate that variable, or no. Oh, we didn't even have to isolate the variable because it was already isolated over there. Okay, so we're skipping our blue step and we're moving straight to simplification. So I need to divide both sides by 10 to get that x all by itself, and we're left with x equals negative 3. Okay, so now that's one way to solve it. The other way we could solve this is, since this equation is divided by 2 on the right-hand side, we could go ahead and split this up into 6x divided by 2 minus 30 divided by 2. And we could simplify that down to where we have 8x equals 3x minus 15, because 6x divided by 2 would be 3x, 30 divided by 2 is 15. And then we could solve it from there. So we would move the variable to one side, so minus 3x on both sides, keep the equation nice and happy. So we're left with 5x equals negative 15. And then we would need to divide both sides by 5 to simplify, get that variable all by itself. We're left with x equals negative 3. So anytime you have an equation where there's a fraction and grouping symbols on that right-hand side, you can solve it either of these 2 ways. Me personally, I like this way on the left better. But really, you can use either way, which